All right, so welcome back. We are now in section 1.4, and what I'm going to do is I'm going to start off with a fairly simple application, one that you wouldn't quite need these advanced techniques to do, but you still can use these techniques, and by using them, I think it'll reinforce the techniques in themselves. But ready? Let me begin with the application. So let's assume that your grandparents have accumulated $220,000 in some type of nest egg, some type of retirement fund, right? And both of them are, let's say, are about to retire. Now, they know what they're going to get every month, say from their Social Security check or from their pension. But they've sat down and they've done up the math and they've figured out that they are going to need an additional $16,000 per year, right? So $16,000 in addition to what they get from their Social Security and pension in order to keep their current standard of living. Now, here's where you come in. So your grandparents have narrowed the investment options down into one of the following. So either a money market savings account, right? So this is kind of like a traditional savings account, but it's a little bit more liquidable than a CD. But nevertheless, a money market savings account, and we'll just make up some numbers here. We'll say that currently gives 2% interest per year. Okay. The other potential investment option is some type of stock, say mutual funds, some blue chip stocks. Nothing too speculative, but it does give a decent return on your investment. And let's say that this investment vehicle yields 8% per year in interest. Now, if the question was simply if you wanted to maximize the amount of money that you make per year, which investment would you choose? If that was the question, well, then you would put all $220,000 into the stocks. But here's the little caveat. So let's say that your grandparents, they really don't trust the stock market that much. They would much rather have their money local, say in a bank or some type of savings account. And so, in other words, yes, they need the $16,000 per year in income, but they want to be able to generate $16,000 a year in income, investing as little of that $220,000 into stocks as possible, right? Now, if they could get $16,000 by putting all of their $220,000 into a savings account, then they would do that, but that's not feasible. So at least an amount of that $220,000, a certain amount is going to have to go into stocks. But we want to minimize that amount. Got it? So now let's start to figure out how you would answer such a question. Well, first off, let's say that let's define some things. So let's say that X in this scenario, let's let X define the amount of money invested in stocks, right? So, and of course, what I mean, X is the amount of the $220,000 that you have invested in stocks. And let's let Y be the amount of that $220,000 that you place into savings, invest into that mutual money market. Okay, So what we're going to do is we're going to try to set up a system of equations. And then we're going to seek the solution to that system of equations, if indeed there is a solution. So, okay, well, let's start with when, of course, all of your application problems, the setup, right, the initial modeling is what makes them hard. But let's see if you can follow me here. So I need two equations. Now, the first equation, x plus y, should equal, well, unless someone's stealing money from your grandparents, if the amount of money, if x is the amount of the 220,000 in stocks and y is the amount of the 220,000 in money markets, then x plus y should equal 220,000. Okay? Now, the other equation in our system, we want this equation to equal 16,000, right? Because that is how much extra they need per year. And we can do that by using these interest rates. So 8%, that's 0.08, and of course 2% is 0.02. So X still represents the amount in stocks, but however much they place in stocks, they're going to get 8% or 0.8 interest on however much they put in the stocks. Plus, they're going to get 2% or 0.02 interest for the amount that they put in money market. So what we want is 8% of the amount in stocks plus 2% of the amount in money market savings. We want that to sum up to be 16,000. So now we have our system. Okay, so again, since this is linear algebra, let's think of this as a matrix, right? It's been a little bit. So let's go ahead and convert this system of two equations and two variables. Let's convert this to a matrix. All right, let's go. Let's grab the coefficients. So I got 1, and then 220,000. And now we'll go to the second equation, grab those coefficients. So 0.08, 0.02, and 16,000. All right, now at this stage, either through row operations by hand or through the use of technology, we've talked about RREF, reduce row echelon form. If we row reduce this matrix, here is the result. 1, 0, 0, 1, 176. I mean, we've rounded a little bit. $176,666, and then $43,333. There's some change left over here, but this is good enough. So what have we just figured out, right? Because your grandparents say have watched you do some math on a paper, and now you want to be able to turn to them and answer the question that they asked. How much must I place in stocks, and how much should I place in money market so that I get 16,000 extra in income per year? And so since the columns translate into variables, so this first column deals with the x variable. So 1, meaning 1x, we just figured out that x should equal $176,666. Y should equal $43,333. And the answer to their question is the minimum amount that they can put into stocks is of that 220,000. The minimum amount is $176,666. As long as they place that minimum amount in stocks, and then the rest of it can go into savings, that will, assuming that these these returns on investments, assuming this stays constant, that will assure them an extra $16,000 per year in income. Notice that they are not living out of the $220,000, right? $220,000 seems like a lot when you're young, but when you start chipping away at it, it can really go quickly. The good news is your grandparents are not living off the 220,000. They're living off of the interest generated from the 220,000. So every year they would be able to continue to gain an extra 16,000 in income. Beautiful. Okay, now what I want to do is this is the matrix way of both viewing and solving this example. How would we view it and solve it in the language of vectors? Right. So let me erase. We already know the answers, so we can only hope that we generate the same answers. But nevertheless, let's keep going. So if you want to discuss the vector equation, right? So what is the vector analog of viewing this system? Well, let's think of it as, again, let's start with our vector equation. So I'm going to use C sub 1 V multiplied by vector V plus C sub 2, and let's say multiplied by vector, I don't know, W. And that must equal some vector, and we'll just call it B. So now the question is, how do we view this example in terms of a vector equation? Well, let's start with the vectors. Let's start with V. Let's start with W. Well, what we're going to do is, if you think back, if you look back through your notes, remember we had the matrix 1.08, 1.02, and then you had 220,000 and 16,000, right? The good news is the columns of that matrix are going to represent the vectors in this problem. Ready? So column 1 is going to be vector V. So we got C sub 1 multiplied by 1.08, okay, plus C sub 2. Oh, my apologies. Let me see if I can draw that better. C sub 2 multiplied by column 2 is going to translate into vector W. And finally, column 3 is going to translate into vector B. So now, we could have phrased this question in the terms of vectors like so. So back to asking how much money should your grandparents invest in stocks, and then how much should they invest in savings in order to guarantee that extra 16,000 in income. To in the language of vectors, it's asking you to find which scalars should be applied to these vectors such that the linear combination of those vectors is equal to the following. And what is the answer to that question? Well, the good news is if you recall, we've already figured out what that answer is, right? We figured out that we got to invest $176,666 into stocks, and we have to invest $43,333 into savings. That the answer to that matrix is the equivalent to the answer to what the weights are for this vector equation. Now, again, working on vocabulary, because linear algebra, again, the hardest part, I cannot stress enough, is shifting through the vocabulary. So, is $16,000 within the span of these vectors? Well, yes, right? You can by investing this much in stocks and this much in savings, you can reach $16,000 per year in additional income. What if everything about this problem was the same, except what if your grandparents asked or mentioned that they need an extra $32,000 per year in income, right? So instead of needing an extra $16,000 per year in income, what if they said they needed an extra $32,000 per year income? Well, the math would be the same. The setup would be the same. And I encourage you to do everything that we just did with this problem, but now use $32,000. Guess what? Quite unfortunately, you would have to turn to your grandparents and say, I'm so sorry, there is no way that your $220,000 is going to be able to generate $32,000 in income given these two investments. There's just no way. Even if you put all of it in stocks, it won't get you to $32,000. So we would say that $32,000 is not in the span of these vectors, right? It's not within the span of that linear combination. Now, I do hope that helps to solidify the language that I've been using. But let me go ahead and kind of lay out where we're going to be going from here, okay? So we're still going to be discussing vectors. And we're still going to be discussing, both vectors, the vector equation, the matrix equation. We are still working on linear combinations, but we want to continue to view linear combination of vectors as the product of a matrix and a vector. So in the next video, when we get back, we're gonna jump in to the following definition, and we're gonna start to, if you recall, when we were learning vectors, remember we had all these little techniques like the dot product or the cross product, right? And in your engineering classes, in your physics classes, you just perform dot products and you perform cross products. You may even know what a dot product or a cross product does for you, but do you know where it comes from and why does it work? And that's what we're going to be focusing on in the videos to come, but I will see you in the next video.